Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic current, potential difference, and resistance. This is a paper video and hopefully this video can help you all in order to solve these type of questions. By the way, if you guys want to change the quality of the video, you guys can do that I think in the YouTube settings of this video itself so that the questions appear to be more clear, and time codes will be in the description box in the description below so that you guys can skip to any question you guys like. And yeah, and if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the questions. All right, so the first question states that all we can see is that there is an electric circuit which is shown in the figure below. All right, so by the way, this worksheet also is taken from a site called Physics and Math Tutor. I know many of you guys know about this, but it's a really good site where you guys can use to find out to find resources based on physics topic itself and other subjects as well. It's really helpful. Do check that out, by the way. And by the way, the current in the circuit is direct current. So what is meant by direct current? So direct current means it's technically current that flows only in one direction. So what we can say is that it's a current that is always in the same direction. So we're going to tick that box here. That's going to be your answer for 1 mark. Let's move on to the next question. Now the next question states that the equation which links current, potential difference, and resistance is potential difference is equal to current times resistance. We have to calculate the potential difference across the battery in the circuit in the figure above. So they're asking us to calculate the potential difference. So what we're going to do is we're going to write down V is equal to, V just stands for potential difference, and here the current in this case is going to be about 0.4 amps, since we know that this is a series circuit, and in a series circuit the current remains the same. So we're going to use the same current of 0.4 amps. It's not going to change, so it's going to be 0.4 amps multiplied by the resistance. Now in order to find out the resistance, what we're going to do is we're going to add both of these resistance up, since the resistance in a series circuit is shared. So what we're going to do is we're going to have 20 ohms plus a bit of 10 ohms, which is going to give us a maximum of about 30 ohms. So once you do that, you can do 0.4 amps times 30 ohms, which is going to give us a value of about, let's say, 12 volts. So now 12 volts in this case is going to be your answer for your potential difference. All right. Okay, let's move on to the next question. Now the next question states that the equation which links current, potential difference, and power is equal to current times potential difference. All we have to do is to calculate the power output of the battery in the figure above, and you have to give your answer basically up to one significant figure. Now in order to do this, is since we already know what the current is from the question itself, that is, it is about 0.4 amps, and we have found out what the potential difference is to be about 12 volts. We're going to use these two values and multiply together to give us the value of power. So power is going to be P is equal to current 0.4 amps times potential difference, in this case is about 12 volts, is going to be equivalent to 0.4 times 12. It's going to be equivalent to about 4.8 watts. Now this is going to be your answer for about 2 marks, so you're going to write down 4.8 watts. So now I've got these two values from the question above and from the answers that we have found. Okay, from the question we got 12 volts from this question, and we got 0.4 amps from the question itself. All right, let's move on to the next question. Now the next question, by the way, a careful consideration is that do not write 4.8 watts directly. The reason is because we have to give our answer to about one significant figure, so do watch that point out. So what we're going to do is we're going to convert 4.8 watts to about 5 watts. That's going to be your answer for about 2 marks. So do read the questions carefully below, and yeah, let's move on to the next question. Now the next question shows us a simple circuit. Now this in case shows us that it is a series circuit where the current is the same, the potential difference is the same, the resistance is also the same. So we have to calculate the resistance is not the same. The resistance, they add up together, since they add up together in a series circuit. So we have to calculate the total resistance of these two resistors in the circuit. So what we're going to do is we have resistance is equivalent to 9 ohms plus 6 ohms, which is going to be equivalent to 9 plus 6 ohms, that's going to be 15 ohms. So now this is going to be your value for total resistance. You're just going to write down 50 ohms. That's it. All right, let's move on to the next question. Now, the next question states that we have to calculate the reading on the voltmeter, and we have to show clearly how we worked out the answer. Now, a nice little formula that I would use is basically use a formula triangle. A formula triangle is like a bonus tip here, is that it's a nice way of representing formulas. So in order to calculate the reading on the voltmeter, you're going to have voltage is going to be equal to current times the resistance. Now, these are just symbols for certain values in this case. So here we have voltage is equal to current. In this case, since we know that this is a series circuit, is that the current is going to remain the same. So it's going to be about 0.3 amps multiplied by the resistance, which we have found from this question above, which is going to be 15 ohms. And we're going to use that to have 0.3 amps times 15 ohms, which is going to be equivalent to 0.3 times 15 to give us a value of about 4.5 volts. Now, are they asking us to convert this to a specific significant figure? No, they're not asking in this case, so we're just going to leave it as 4.5 volts as it is. Now, let's move on to the next question. Now, the next question states that we have to draw a ring around the correct answer in the box to complete the sentence. Replacing one of the resistors with a resistor of higher value will do something to the reading on the, let's say, on the ammeter. So what's it going to do? It's going to decrease the value as you increase the resistance. So you're going to circle out decrease. You're going to circle decrease the reading on the ammeter. Okay, let's move on to the next question. Now, the next question states that the voltmeter in the circuit is replaced with an oscilloscope. Now, which one of the diagrams X, Y, Z shows the trace that was be seen on the oscilloscope? You have to write our answer about X, Y, Z in the box. So now you guys can see that there are 3 diagrams shown. So the one for the trace that would be seen on the oscilloscope would be Y. Now, the reason is because the thing is that direct current, because Y shows, basically what we're going to say, it is the only one that shows, it shows a direct current. That's what you're going to mention for 2 marks, right? It shows a direct current. Now, 2 marks is where 1 mark where you state the value of Y, and the other one for the reasoning where it shows a direct current. Now, you can give other answers as well, because the battery, if you look at the diagram, is that since it's a series circuit, is that the battery gives like a direct current, or you could say that the battery or the cell gives a constant current or potential difference. Those could also be your answers as well in this case. Let's move on to the next question. Now, the next question states that the diagram shows the information played on an electric kettle. The kettle is plugged into the AC mains electricity supply. Now, this is where you need to understand your content learning stuff. So we have to know what is the frequency of the AC mains electricity supply. Now, this is something that you guys have to remember in your exams. So it's going to be about 50 hertz. That's going to be your answer. And your the next question states that what's the power of the electric kettle? Since we know that power is in watts, we're going to say that's going to be about 2,760 ohms. So that's something that you guys should know when dealing with this, all right? Now, next question is that to boil the water in a kettle, you need about 2,400 coulombs of charge that passes through the heating element in about 200 seconds. You have to calculate the current flowing through the heating element and give the unit. Now, the unit for current is that you all should know that unit of current is about amps. You're going to circle that up, and we're going to use that in the answer below, all right? So we're going to use a nice little formula triangle here, QIT, where Q just represents the charge flow. We're going to write it down in coulombs, all right? And I represents the current times T. T represents the time in seconds. So I'm going to rearrange this formula to make I the subject of the formula. You're going to use that in maths. Is equivalent to 2,400 coulombs divided by 200 seconds. So we'll rearrange the formula where I, which is the current, 2,400 coulombs divided by 200 seconds, which is going to give us a value of about 12 amps. So you're going to write down 12 amps here, or you can write it as 12A as well. Doesn't matter, you're just going to write it down as 12 amps since we have to choose a unit from the list below. Right, that's for 3 marks. Let's move on to the next question. Now, the next question states that the amount of charge passing through the heating element of an electric kettle depends on the time the kettle is switched on. So you can see a nice little diagram here where the charge in coulombs with the time the kettle is switched on. Now, what pattern links the amount of charge passing through the heating element and the time the kettle is switched on? So as you guys can see, that there's a nice little straight line. So that shows us that the charge in coulombs is directly proportional to the time switched on. So what I'm going to say is that the charge is directly, I'm going to write those keywords down, is directly proportional to the time switched on, right? You could also mention that they are, or you could mention that there is a positive correlation. That could be another point that you guys can write down for an answer. You can also mention that they are proportional to each other. You can also mention that the longer the time it takes to boil, the greater the amount of charge that's been given. Alright, so let's move on to the next question. This should be your answer for this type of graph questions. Alright, next question states that the electrical circuits often contain resistors. The diagram shows two resistors joined in series. They've already mentioned that this is a series circuit, and we have to calculate the total resistance of the two resistors. You should remember that resistance in series circuits, they add up together. So you're going to have resistance is going to be equivalent to 10 ohms plus 15 ohms, which is going to give us a value of about 25 ohms. All right, so this is going to be 25 ohms. All right, let's move on to the next question. Now, the next question states that a circuit was set up as shown in the diagram. The three resistors are identical to each other. So you can see there's a 6-volt battery and there are three resistors. You have to calculate the reading of the voltmeter. So you have to remember that in series circuit is that the potential difference is shared. Now, these are some rules that you guys have to remember about the series circuit. Okay, so we know that there are 6 volts. It's going to be divided by these three resistors here. So that's going to be 6 volts divided by 3 resistors is going to be 2 volts per each resistor. All right. So as you guys can see that the reading on the voltmeter is going to be 2 volts. 2 volts added up to 2 volts is going to be 4 volts. 4 volts added up to 2 volts is going to be a total of about 6 volts. So that's the reason why this is 2 volts for 2 marks. All right. Let's move on to the next question. Now that the same circuit has now been set up with 2 ammeters, you can see that it's again a series circuit where the current is the same. You should be noticing that the reading on the ammeter of A2 of this ammeter will be equivalent. We're going to draw a ring around the answer. It's going to be equal to the reading on ammeter A1. Now that's the reason because in a series circuit, the current is always going to be the same. So you're going to use the same idea and logic in order to solve this type of question. All right. Let's move on to the next question. Now, the next question states that you have to draw one line from each circuit symbol to its correct name. Now, this is another form of content learning that you guys have to remember while dealing with this type of questions. So the circuit symbol here is that you can see that this is a lamp. So what we're going to do is we're going to draw something like here from lamp to lamp. This is a diode, so it's going to be, but it's not a diode, it's a light emitting diode. So you have to be careful with what you mark down. Then you have a resistor. This is a light dependent resistor. You guys can see the arrow marks that can help you guys understand how to judge whether this is a light emitting diode or a light dependent resistor, and also from the inside parts of the circle, right? So you have these two values here, and yeah, I think that's it. And figure 1 shows that there are 3 circuits. The resistors in the circuits are identical. Each of the cells has a potential difference of about 1.5 volts. So since this is about 1.5 volts, the next circuit is going to be 1.5 volts times 2, which is going to be about 3 volts for this circuit 2. For circuit 3, it's going to be 1.5 times 3. That's going to be about 4.5 volts for this question as well. So we're going to have 4.5 volts for this. Now, the resistance of circuit 1 should be half the resistance of circuit 3. All right, so that's going to be our answer. You have to calculate the reading on voltmeter 2. We have already calculated the reading on voltmeter 2, which is going to be about 3 volts. Since we're multiplying, we can state it down there that 1.5 volts is multiplied by 2, which is going to give us a value of about, let's say, 3 volts. Okay, so this is going to be your answer for your voltmeter reading. So it's going to be about 3 volts. Next question is that which voltmeter, V1, V2, or V3 will give the lowest reading, and you have to draw a ring around the correct answer. So the lowest reading here in this case would be the V1. That's because it's only like about 1.5 volts. So it's going to be V1, we're going to circle V1. Now that's going to be our answer for this type of question. Let's move on to the next question. Now the next question states that a student wanted to find out how the number of resistors affects the current in a series circuit. And figure 2 shows us the circuit is used by the student. You can see a battery, you can see a switch, and this is again a series circuit. Now the student started with one resistor and then added more identical resistors to the circuit. Each time a resistor was added, the student closed the switch and took the ammeter reading. The student used a total of about 4 resistors. So figure 3 shows the 3 of the results that is obtained by the students. As you guys can see that there's a nice little bar chart. I've already written down some of the answers here. So to get the valid results, what does the student need to keep, which variable the student needs to keep same throughout the whole experiment? So since you guys can see that there's current and there's a number of resistors, you know that they have to use, let's say, they have to keep the potential difference or the voltage of the power supply the same. So we're going to mention that they have to keep the potential difference of the power supply the same. You can also mention voltage of the power supply, and that's also fine. Or you could also mention the number of cells or the batteries, and that's also fine as well. Now the bar chart in figure 3 is not complete. The result is using 4 resistors is not shown. You have to complete the bar chart to show the current in the circuit when 4 resistors were used. Now if you guys can see a trend here between the bar graphs is that as the number of resistors increases, right, the current in amps decreases. So I've drawn roughly about with the same width. I've drawn a bar graph about the same width of the spacing, and as well as the width of the bar chart, or the bars are about 6, so I've kept like 6 squares there, and I've drawn it up to about 1 amps. So this is, and I've also shaded it just to mention that this is about this is a bar chart that's drawn for about 4 resistors, and I've divided 1 divided by 10 in order just to find out how much each square is worth in its value. So that's one way of doing this type of question. Now what conclusion should the student make from the bar chart? Now, like I said, if you guys have noticed from the bar chart, if you guys analyze it, is that as the number of resistors in series increases, the current in amps decreases. So what we're going to do is we're going to mention that in this type of question. We're going to write it down. And remember, the bar is drawn at the height of about 1.0 amps, so that's okay as well. So you have to write as the number of resistors increases, as the number of resistors increases, alright, the current decreases. Now that's going to be our answer for about 1 mark. So you're going to write that down as well, alright? So as the number of resistors increases, the current decreases. Alright, let's move on to the next question. Next question states that a student wants to investigate how the current through the filament lamp affects its resistance. So I've drawn a nice little diagram of connecting all of these circuit symbols together. So you guys want to take notes on this one as well. So what you're going to do is you're going to draw like a connection between the 12-volt battery with an ammeter which is connected in series with a filament lamp also connected in series and a variable resistor also connected in series, and then I have connected the voltmeter parallel to the filament lamp. Okay, that's really critical that you guys take notes on this, is that the voltmeter should be in parallel with the filament lamp, while the battery, lamp, and ammeter should be connected in series with the variable resistor. Remember, voltmeter is always in parallel with the filament lamp. Now they're asked us to describe how the student could use her circuit to investigate how the current through the filament lamp affects its resistance. So I've written down the answer already, since in order just to save up time. We know that the ammeter is used to measure the current in amps. The voltmeter is used to measure the potential difference, if you guys have noticed. In volts, I've also mentioned that it is in volts. And that resistance could be calculated from the formula R is equal to V divided by I. This is the same formula that we have used is VIR, where the resistance is equal to the potential difference divided by the current. And we can use a variable resistor, could be used to change the resistance value. Now all you need to do is you just need to mention 4 points, 4 good valid reasons, and you can score those good marks. Let's move on to the next question. I'm just going to hold this for you guys just to see the diagram again, and this answer as well. Alright, let's move on to the next question. Next question states that the students' results are shown in figure 1. So you can see a nice little diagram there where you can see the resistance in ohms along with the current in amps. You have to describe how the resistance of the filament lamp changes as the current through it increases. So as you guys can see, as the current in amps increases, the resistance also increases as well. So you can say as, for 1 mark, as current increases, you can say that resistance increases as well. Okay, you can mention that resistance increases at an increasing rate. Okay, let's move on to the next question. Now you're going to use figure 1 to estimate the resistance of the filament lamp when the current is about 0.10 amps passing through the lamp. So since it's about 0.10, the resistance is going to, let's say, it's about 0.10, right? Wait, if at 0.10, you're going to mention that it could be about, let's say, 6 point, somewhere around, since it's a 0.0, not 0.10, sorry guys, reading this decimal, it's actually 0.1. I think this 0 there, I think it's 0.1, guys. So the 0.1 reading on the question states that if it is 0.1, then the reading would be roughly about, let's say, 6.2. I think about 6.3, 6.4. So I'm going to write down 6.4. Guys, this is not 0.10, 0.1, okay? While reading the decimal value. So it's going to be 6.4 ohms. That's going to be your value in that case. Now, the current potential difference graphs of 3 components are shown in figure 2. Now, you're going to use answers from the box to identify each component. They've given us the values and the words to use. And now this is very critical when dealing with electricity chapter, is that you have to know what each graph stands for. In figure 2, you can see that the first graph is where this represents a filament lamp. The second graph is where a resistor at constant temperature. And the third graph is a diode graph. And why there is no values on the other side is because the resistance is really high on the other side for a diode. So it's going to be filament lamp, resistor at constant temperature, and it's going to be diode. Okay, that's it. Let's move on to the next question. Now the next question is, again, I've written down the answer just to save up time. Right, is that you can see that the resistor is a component that's used in an electric circuit. You guys can see that this is a series circuit, and we have to describe how the student would use the circuit to take the readings necessary to determine the resistance of resistor R. So this is the same case again, where we have to explain like about, I think, maximum of about 6 points. So you can say that you have to switch on the circuit first. You got to read the values on both the ammeter and voltmeter. You're going to use the variable resistor here to change the current. You're going to draw a graph of about V against I, and you're going to take a mean. You're going to use a formula such as R is equal to V divided by I. Again, resistance is equal to potential difference divided by the current. Now you're going to take the gradient of the graph to find out the resistance. Now these are some 6 points that I've written down for this type of answer. You guys can write down other points as well if you guys want to score those good 6 marks. Let's move on to the next question. Next question is, explain why the student should always open the switch after each reading. Now this is like a safety reason that you're going to say that the resistor like could get hot if the current was left on. If the current is left on, which would make the resistance increase in value. Okay, so what do I mean by this is that the resistor, if it gets hot, if the current is left on, is that the resistance would increase indirectly. That's what would happen, which would make the resistance increase. That's for 2 marks. You're going to write that down. Now next question is that in an experiment using the circuit, an ammeter reading was about 0.75 amps. Is that the calculated value of the resistance of resistor R is about 16 ohms. What is a voltmeter reading? Now this is again the same formula, VIR, where the voltage is equal to current times the resistance. You have voltage is equal to current is given to us as 0.75 amps in the question below, times let's say the resistance was 16 ohms. That's also in the question, is equivalent to 0.75 times 16. I'm using the calculator, guys. Do use a calculator, is really helpful. So it's going to be about 12 volts. That is going to be your answer for about 2 marks. Now, the student told his teacher that the resistance of resistor R was about 16 ohms. Now, the teacher explained that resistors could the resistors used could only have about one of the following values of resistance. So suggest which of these resistors the student had used in his experiment. So the student is going to use about, let's say 15 ohms, because it's pretty close to the value of 16 ohms. So we have to give a reason. So I'm going to use the same reason again. Is that the student used a value. Let's say student used the value of 15 ohms, since we're going to use that value since it is closer to the value of 16 ohms. So the student used the value of 15 ohms since it was closer to the value of 16 ohms. That's going to be our answer for about 2 marks. That's the most, because 15 is pretty close to 16 itself. All right. Let's move on to the final question. Is that the diagram shows a fuse. You have to describe the action of the fuse in a circuit. Total marks for it is about 3 marks. You're going to mention like 3 points. So we're going to say that in a fuse, basically whatever, if the current is above the value on the reading of the fuse itself, it's going to explode or melt, break, and which would indirectly basically close more likely open the switch or something like that, and it's going to break the circuit in this case. So we're going to mention those points as well in this question. So if the current, I'm going to write that down so you guys can all see that. If the current is above 5 amps as mentioned in the question, or the value of the fuse, I'm going to mention it's above 5 amps. It's going to be, this is a 5 by the way, is above 5 amps, then the fuse melts. Then the fuse melts, which breaks the circuit. So this is some points that you guys are going to mention for 3 marks. Is that if the current is above 5 amps or the value of the fuse is going to melt, either blow or break. Those words are also allowed, or it's going to, and which indirectly breaks the circuit. So you're explaining the reason why the value of the fuse causes the fuse to melt, and why indirectly it breaks the fuse, which indirectly explains the action of the fuse. So you're going to mention that if the current is about 5 amps or the value of the fuse indirectly melts, blows, or breaks, and which indirectly breaks the whole circuit in order for safety reasons. Now this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video, on whether I should continue solving questions related to past papers or to topic by wise questions. And yeah, do stay motivated. New content will be posted soon. I think that's it, guys. All right. Bye, guys.